Hi, I'm Adolph Oliver, and this is a video clip about solving quadratic equations. We've been spending a lot of time lately learning how to factor quadratics, and this is where we're going to be able to show you why we've been doing that. So first thing, anytime you have a quadratic equation, and you know it's quadratic because there's a term that has a variable to squared, in other words, see the x squared here? Okay, that's definitely not linear, that's quadratic. So what you can do is move everybody to the left, so you end up with ax squared plus bx plus c equals 0. This 0 over on the right is real important, as we'll talk about in a moment. The a, b, and c, of course, are just the coefficients of each of the terms. Now, this guy on the left is a quadratic. Factor him using any of the methods you've learned. Since the right side equals 0 over here, we can also use now what's known as the zero product rule to get the answers to the equation, and these answers are known as the roots of the equation. Okay, well, let's demonstrate to you how this works with a beginning example. We have an x squared term. That means it's a quadratic. First thing you do is you move everybody over to the left, so you have a 0 on the right. So if I do that, the x squared was over here already. I'll bring over the negative 2x, which as it jumps across becomes positive 2x. And then the plus 8 comes over as negative 8. And that, of course, now means since we moved everything on the right away, we've got a 0 over here. And that, of course, is what we always want before we ever try factoring the left. Well, this is a nice little reverse FOIL here. So let's remember or remind ourselves how this goes. What I want is two numbers here that will give me 8 when I multiply them together. The minus here in front reminds me I also want their difference to be 2. Now, if this would have been a plus in front of the 8, then what we would have done was we'd say sum, not difference. Okay, remember how the reverse FOIL works in factoring these guys. Well, this one's not difficult. Two numbers that multiply together to give me 8, whose difference is 2. How about 4 and 2? Okay. 2 times 4 is 8. The difference between 4 and 2 is 2. So this is the winning combination here. Now, of course, you see the minus here in front of the last term? That meant, of course, the signs are one of each. In other words, a plus and a minus. Now, we can start factoring this, and of course, reverse FOILs go real nice. Let's set it up. The variable's x, and I'm going to have a plus in one of the binomials, and then the variable x and a minus in the other, and of course this still equals the 0 we got on the right. Well, remember, whenever the signs are different like this, you got to be careful. You got to make sure you get everybody in the right place. So you play what I call the bigger game. The 4 is bigger than the 2, and it has to have the sign of the center term. So that means the 4 goes with the 2. The 4 goes with the plus. And where'd I put the plus? Right here. So there's the 4. The 2 goes in the only hole left here. Now, let's double check this to make sure that it works. If I FOIL this, and we'll just point it out here, x times x would give me x squared. Plus 4 times negative 2, the last, would give me negative 8. And then if I did the two rainbows here, okay, I get minus 2x on the big rainbow, plus 4x on the little rainbow. Combine those and we do get plus 2x. So you can see this is the correct factoring. Now, of course, we've got to show you how you come up with the roots of the equation. That's why we've been learning all of this factoring, to be able to do this. Here's the idea. If you got two things multiplying each other, and the parents here, there's two of them, and they're multiplying each other because the parents are next to each other, then if the answer is 0, that means one of them's got to be 0 or the other one's got to be 0. So we simply ask ourselves this: what values of x would make, for instance, this first guy right here 0? Well, x plus 4, if I wanted to make this 0, x would have to be negative 4. Negative 4 plus 4 does indeed give me 0. So there's one of the roots. Okay, going over to the next guy here. X minus 2. Well, what value of x makes this guy 0? 2. I'll put the plus to rub it in here. Plus 2 minus 2 equals 0. So these are the two roots. Now, we can turn around and say, okay, the roots to this, if we have more than one answer, remember we can put them in the curly set brackets like this. But now, let's test these guys to make sure that they are indeed the roots. So here's how we can do that. Okay, this one on the left over here, I think x equals negative 4 is one of the answers. Well, take the original equation back up here. X squared, I'm going to make a hole for the x, there's the squared, equals 8 minus 2 times and a hole for the x. Well, we think x equals negative 4 is one of the answers, so let's put it in here, the negative 4. Now, this has to balance if this is correct. So negative 4 times negative 4 is 16. Over here, I've got 8, and then minus 2 times minus 4 gives me plus 8. Well, 16 equals 16, huh? We're good. So that means that negative 4 is good. Well, let's go try the 2. It's going to work, but here we are. So if x equals 2, I left the plus sign off, but we know it's positive. Again, go to the original equation up here, but now make holes for the variable x to be able to substitute in. And here we go. Okay, here's a hole for the second x. Now, we think it's 2 this time. So here it is. What's 2 squared? Well, that's 4 equals 8. Minus 2 times 2 is minus 4. Well, look at this. This works too. 4 equals 4. So we can see that these two values here that we got, the roots of the equation, are definitely good answers. Well, this is a process we're going to do, and this is why we spent all this time learning how to factor these quadratics so that we can use the zero property rule once we factor it to be able to come up with the answers. Okay, let's look at some more examples here so you can get the idea of how it goes. This one right here, they've been nice to us. Everything's moved to the left already. This is a quadratic. You can see the squared term. And of course, we have the required 0 on the right. So we're all set to factor this. Now, we got a nice plus 1 in front, so that means it's a reverse FOIL. So I want two numbers multiplied together. Give me 35. The minus here reminds me I want the difference of those numbers then to be 2. Well, this is not hard to figure out. What two numbers multiply together give you 35 whose difference is 2? How about 5 and 7? 5 times 7 is 35, and the difference between them is 2. Okay, well, again, we got a minus in front of our last term, which means the signs are one of each. Okay, a plus and a minus. Now, put them down where you want, because we're going to play the bigger game in a moment to get the winning combination in the right spot. So here we go. Let's say I feel like putting a minus here, and then I'll put the plus here, and then of course this equals 0. Now, we got to play the bigger game. 7 is bigger than 5, so 7 has to have the sign of the center term, which is positive. So I put the plus here, so that's where the 7 goes. 5 goes in the other spot. Now, what value of x will make this guy equal to 0? Well, x equals positive 5 will do it. These simple ones like this, you learn real quick that the root is just the opposite sign of the plain number here. So likewise over here, what root will we get from this? What will make this 0? Well, since this is plus 7, minus 7. So there are our two answers. You could plug those in just like we did the last problem, and they would both work. -7 and 5 are the answers to this quadratic equation. Now, I want to point out to you that once in a while you get some simple things, and here's an example. This is a quadratic again because it does have a squared term, but notice there's no plain number. We have n squared plus n. Well, when the plain number is missing, the beauty of this is just factor out the GCF, which happens to be n. So I factor the n out, that leaves 1 here, and n plus 1 here. And of course, this is still equal to 0, our required value on the right. Now, if you multiply this back, n times n is n squared, n times plus 1 is plus n. Well, okay, we can see the root of this first guy is -1. Now, this one over here, you think, oh my, what am I going to do with this? Well, if you want to, you can think about putting parents around it. It's still multiplying it. What value of n makes the inside of this parents equal to 0? Well, just 0. So, here we go, the two roots here, -1 and 0. Now you think, can 0 be right? Oh yeah, it's the easiest to see. Look at the original equation. If n is 0, then n squared is 0, plus n, which is 0. You got 0 plus 0, that certainly equals 0. And if you plug the -1 in, that would work also. Okay, let's look at something that has a little bit more to do with it. We got to do some initial cleaning up on this guy right here. Again, you see the squared term here? That means it's a quadratic. So how do you solve quadratics? You got to move everybody to the left so you get a 0 on the right. So that's the first thing we're going to do. I start out with the 7k squared, nobody else to combine with that. Now the plus 4k will come over as minus 4k. Plus 4 to minus, that gives me -18k. And then the -8 goes over as +8. So I've moved everybody to the left, so I've got the required 0 on the right. Remember, never waste your time factoring the left unless you've got a 0 on the right, because you need that 0 over there to figure out what the roots are and to play the 0 product game. Okay, well, first thing to notice here. Okay, it's a quadratic, of course, but we can't use reverse FOIL because this 7 here is not a nice +1. So we got to use AC product. Well, remember what you do in AC product. You multiply the A coefficient times the C coefficient. 7 times 8 is 56. There it is. Now this is what we play the two-number game on. I want two numbers multiplied together to give me 56. Notice now we got a plus in front of the last term, so that means we want the sum of these guys to be 18. Well, okay, let's see what we can do. 2 times 28, okay, 40, that's 56, but the sum is 30, that's way too much. So let's see, 3 won't divide into 56, but 4 will. So I can go 4 times. Now, since I doubled the 2, it means I got to have this guy. 4 times 14, if you multiply it out, will give you 56. Ah, look at this. The sum of 4 and 14 is 18, isn't it? So here it is. This is our winning combination. Now, the next thing to notice here is that the final term over here has a plus in front of it. Remember, if you have a plus in front, that means your signs have to be double plus or double minus. How you decide which one? Look at the sign of the center term, and whichever one it matches. There you go. Since this is minus, it matches the double minus. So we know this is going to factor into the following here. And of course, here's what we have to do. Anytime you do the AC product like this, remember that you've got to do the center term here. Split it, and you split it with the winning values. So here we go. I've got -18k. Take them in either order. I'll just do the order I've got here. So negative 4k and then negative 14k. Now notice these two combined to negative 18k. Remember, in the AC product, you bring down the last guy the way he is, bring down the first guy the way he is. Okay, what we have now are 4 terms, and what we're going to do is factor these by grouping. This is how you finish up to get the answer when you've got the AC product. So, grouping the first two and last two. Okay, pull a GCF out of each of these. Let's see, the only thing common here I think is one of the k's. So if I factor out a k, the leftovers for this first guy are going to be 7k, and the leftovers for the second guy are going to be negative 4. Now double check this to make sure you're right. K times 7k is 7k squared. K times negative 4 is negative 4k. Okay, let's see what we can factor out of this guy over here. Most of the coefficients here are even, so we can get it 2. Yeah, so it looks like 2 is what we can factor out. But remember, of course, we always have the option of factoring out either the plus version of the 2 or the minus version. Compare the signs, first to first, second to second, to see whether you're going to do the plus or minus version. Well, the term down here is plus. This is minus, so they're opposite. The second term is minus here, and it's plus, so the signs are opposite. If they're opposite, you factor out the minus version. If they matched, were the same, you'd factor out the plus version. Well, these being opposite means we factor out a minus 2. So when we do that, what's left over? Well, from the first guy here, 7k, and from the second guy, minus 4. Okay, notice that we have a common 7k minus 4. This is the GCF in our last step. So we turn around now and factor that common guy out. Here it goes. 7k minus 4. Okay, I factored out of both of these. What are the leftovers? K minus 2. Okay. Now, let's remind ourselves, I haven't written it down for a while here, but the right side equals 0. Okay, well, here we are. Now we have to come up with the roots to the equation, the values for k, that if we plugged them back into the original equation up here, it would balance. Well, we're used to doing a simple guy like this. K minus 2 means, I'll put a plus to rub it in, if k is plus 2, okay, 2 minus 2 gives me 0. Now, here's a quick way for getting the second guy. Take the opposite of the plain number, which is positive 4, and then divide it by the coefficient here, 7. Well, if you put in k equals 4/7, the 7s would cancel. You input 4 minus 4, you'd get 0. So that works. Nice little trick for solving this. So here are the two roots here. Okay, we've got 4/7. Okay, and the second guy is 2. Okay, well, this one we had to use the AC product rule. The guy up at the top up here had a nice plus 1 in front of the x squared. We could just use reverse FOIL. So whatever is appropriate for the problem, that's what you want to use. Let's look at a couple more examples here. Here we go. Guy up on top here looks like he's going to be an AC product again. Let's see what happens. Here we go. It's a quadratic because we got an x squared. So that means we got to move everybody to the left. So the 15 has to come over. So when I do that, I've got 6x squared plus x, and the plus 15 comes over as negative 15. Okay. Well, here we go. Got to be an AC product because you don't have a nice plus 1 in front. So the first thing we do is take A times C, and we end up with 90. Okay. Remember, we don't worry about the signs now. We'll get those in a moment. Just multiply the numbers. Okay, well, I want two numbers multiplied together give me 90. The minus here means I also want the difference of those numbers. Well, what's the coefficient here? You don't see one, so we can put in 1. Oh, this is not hard. What two numbers multiply together to give you 90? And the difference is 1. How about 9 and 10? Huh? 9 times 10 is 90. Difference between 9 and 10 is 1. So once again, remember what we do here is we split the center term using these guys. Now, look at the last term here. The sign is minus, so that means we're going to have one of each of the signs. One will be plus and one will be minus. Well, we got to play the bigger game, as always, when we have to decide between plus and minus. 10 is bigger than 9, and it will have to have the sign of the center term, which is plus. Okay, so let's say I do the 10 first then. So plus 10, and we got the variable x, so I put an x here. The 9 has to be the other one, minus 9x. Now, it doesn't matter which way you go with this. You'll get the answer the same either way. So it's Fielder's choice here. But now remember, bring down the first guy exactly like he is. Bring down the last guy exactly like he is. Okay, here we go. 2 and 2. Finish it up, factoring by grouping. Well, let's see. I can factor out an x, and looks like there's a 2 common. So 2x times 3x plus 5. Let's double check this. 2x times 3x gives me 6x squared. 2x times plus 5 gives me plus 10x. Okay. What do we got here? Looks like just a 3 is all that's common here. So let's see what we can do. Well, first off, compare the signs. Plus to minus is opposite. Plus to minus is opposite. Okay, so the signs are opposite, so that means we factor out the minus version of our 3. Okay, and now what's going to be left? Well, what's left after you factor a minus 3 out of minus 9x? Looks like 3x. And what's left when you factor minus 3 out of minus 15? Looks like it's plus 5. Now let's double check this. Negative 3 times 3x is indeed negative 9x. Negative 3 times plus 5 is negative 15. Okay, well, look what we got here now. We have a common quantity in here, and this is always guaranteed to work with AC product. If you didn't make any mistakes up here, this will happen. Now, let me write this over on the right a little bit here, where I've got a little bit more room to finish it up. Okay, factor out the common 3x plus 5 times the leftovers 2x minus 3. Okay, and this equals, of course, our required 0. Remember, we had that earlier up here, so I'm just rewriting it again. Okay, remember that trick again to figure out how to get these roots when it's a little more complicated like this? Take the opposite of the plain number and divide by the coefficient in front of your variable. Negative 5/3. If you plug that in, that will make this guy 0. Similar here, okay, take the opposite of the plain number, which is 3, and divide it by the coefficient of the variable there, 2. Okay, here are the two roots, or answers, that would solve this. I'll write them up here where I got a little bit of room. Negative 5/3 is one of them, and 3/2 is the other. Okay, well, let's look at one last example here. We're going to have to do a little bit of cleaning up on this guy. Again, you can tell that he is a quadratic because you've got variables that are squared. That means everybody gets moved to the left. So, okay, the negative 7m squared is coming over. The negative 42 is coming over. And don't forget the plus 1, it's got to come over as well. So this is all cleanup here to get the required 0 on the right. Negative 7m squared comes over as positive 7m squared. So what are we going to end up with here? It looks like 18m squared. Now, We'll put the m to the first power next. There's no m to the first powers here. So if we jump the negative 42 over, it becomes positive 42m. Okay, the last thing to jump over is the plus 1. It comes over as minus 1. So plus 24 equals 0. Okay, here we go. All cleaned up. And of course, let's see. Oh, we can actually simplify this a little bit. Notice there's a common 2 in all of the terms. And I don't think 4 will work, not into 18. So to make our work a little easier, if you happen to see something like this, this is perfectly legit. Remember, you can always multiply both sides of an equation, each and every term, once and only once, by something, or you can divide as well. Okay, so I'm going to divide by 2, each and every term. Here we go. Even the 0, officially, not that it's going to do much, but officially we do it. Okay, 18 divided by 2 is 9m squared. 42 divided by 2 is plus 21m. And then 24 divided by 2 is plus 12. Now let's make sure 2 times 12 is 24. 2 times 21m is 42m. 2 times 9m squared is going to be 18m squared. Okay, looks good. And of course, 0 divided by 2 is just 0, so there's the required 0. Okay, well now, well, the reason we did that is our AC product's going to be smaller now, and anytime we can make our numbers smaller, that makes our work easier. So we still have to do an AC product because the coefficient of the squared term is not 1. So 9 times 12, let's see, I think that's 108, isn't it? 9 times 12 is 108. So we want two numbers, okay, multiplied together, give me 108. The plus here means then I want the sum to be 21. Well, okay, let's look at some possible combinations. One of them here, you could go, of course, 2 times 54, but the sum of that is way too big. Let's see, 4 will go in here. 4 times 27, sum of that is 31. Well, we're heading the right way. Let's see, 5 won't go, doesn't end in 0, 5. 6 won't go because 3 doesn't. No, actually 6 would go, wouldn't it? Let's try it and see. 6 times, 6 goes into 10 once. That leaves 48. 6 goes into 48 18 times, huh? So let's check this. 6 times 8 is 48. 6 and 10, that's 108 for sure. The sum is 24. Well, hey, we're getting real close. The next one ought to do it. Let's see. Well, 7 go into this? No, I don't think so. Let's try 8. Okay. 8 goes into 10 once. Okay, that leaves 2. 8 goes into then 28. Well, that's not going to work. So 8 is not going to work for us. Let's see. Let's try 9 then. If it doesn't work, just cross it out. 9 goes into 10 once. Okay, and that leaves me a 1 and 8 twice. There we go. So 9 times 12 is 108. Oh, look at this. Here's our winning combination. Because what's the sum of 9 and 12? 21. Sometimes you got to work a little bit for it, but there it is. This is factorable. So the winning combination, 9 and 12. Now, notice this. The last term here has a plus in the term, so our choices are either double plus or double minus. Look at the sign of the center term to decide which. And since the center term is positive, we take the double plus. Now remember, this is an AC product. So what we do is we use these winning numbers to split the center term. We know they're both going to be positive. So plus 9m and plus 12m. Take them either way you want. Bring down the last guy exactly how he is. bring down the first guy exactly how he is. Well, this ends up with 4 terms, which we can then use factor by grouping to solve these. Okay, well, let's see. It looks like the GCF in the first two is 9m, huh? And what are the leftovers going to be? I think it's just m plus 1. Okay. Now, oh yeah, there's a common 12 here. Notice the signs match. Plus to plus, plus to plus. So since they match, that means we factor out the plus version of the 12. Okay, and I factor 12 out of 12m. I end up with just m. And 12 factored out of 12 just leaves 1 there. Now let's double check this. Plus 12 times m is plus 12m. Plus 12 times plus 1 is plus 12. Okay, well, we now can factor it completely. We've got the common m plus 1. Here it goes. What are the leftovers? Well, 9m plus 12. Okay. Now, notice one thing here. We can factor a 3 out of this, but since we're finding the roots, we'll just reduce the root when we get it. So you can do it either way. Let's, and of course, remember, we had this equal to the 0 up here, so there that is. Okay, root of the first guy is real simple. Just take the opposite of the number. The coefficient is 1, so negative 1 divided by 1. Negative 1, you just look at that, knew it was negative 1 anyway. Now, this guy here, the opposite of the plus 12 is minus 12 divided by 9. But of course, we got to reduce this. Remember, fractions have to be reduced wherever they show up. 3 will go into the bottom 3 times. Okay. And 3 will go in the top 4 times. So negative 4/3. Okay, well, here we go. We've got our roots or answers to this last one. This guy took a little bit of more cleaning up. Remember, to begin with up here, we had to move everybody to the left. We had to do the AC product, took a little figuring out for what the winning combination is. But here we go, the roots, negative 4/3 and negative 1. They're really correct any order you put them in, but I always like to have them in numeric order. Negative 4/3 will be, negative 1 1/3. Further to the left on the number line than negative 1. So there we are. Well, okay, you've been able to see here why we go through and learned all of that factoring business, because it's the key here to be able to come up with the answers to quadratic equations.